Hello, my dear children. Now, today we are going to discuss continuity and differentiability. Exercise 5.4 sums. In the previous class, in the last class, we have discussed the concepts or points. Okay, my dear children. I hope you have learnt well. I hope you got the knowledge of the concepts of this exercise 5.4. Okay, my dear children. Right. Now, see page number 174. Page number 174. First question, exercise 5.4. Question number 1. Differentiate e power x by sin x with respect to x. Understood the question, my dear children? We have to differentiate this function with respect to x. To differentiate this function with respect to x, there are two methods. How many methods are there? Two methods are there. The first method is by using the previous knowledge. What is the previous knowledge? By using the quotient rule, because it is in the form of numerator by denominator. So we can use our previous knowledge of quotient rule to differentiate this function. Okay, my children, I will explain the two methods. You can follow any method which is easier to you. Okay, my children, right. Let us consider y is equal to e power x by sin x. Okay, my children, differentiating with respect to x. Previously, I told you many times this sentence stands for differentiating with respect to x. This is the short form of that sentence. Okay, my children. So here we are differentiating the both functions on both sides with respect to x. Then what is the differential operator? D by dx. Yes. So we are writing d by dx on both sides before the functions. So d by dx of y is equal to d by dx of e power x by sin x. Understood this step, my dear children? Right. This implies in the LHS, what is there? D by dx of y. Then what is the value? D by dx of y means dy by dx only. So I wrote this one. Understood this LHS part, my dear children? Right. Now come to RHS. It is in the form of d by dx of f of x by g of x. Means we have to use a quotient rule. So this is f of x and this is g of x. Consider these two functions as f of x by g of x in your mind. Okay, my children? Then g of x, that is sin x into d by dx of f of x, that is e power x. Understood this first term, my children? Right. Minus f of x. What is f of x? E power x into d by dx of g of x. What is g of x here? Sin x. Understood this is second term in the numerator, my children? Right. Whole divided by g of x whole square. What is g of x here? Sin x whole square. Understood the denominator part also, my children? Right. Here, whatever I used the formulas, I wrote here clearly, because d by dx of y is equal to dy by dx. D by dx of f of x by g of x is equal to g of x into d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square. This is called quotient rule. Okay, my children, remember these formulas well. Right. Now come to the LHS. Dy by dx, we are writing LHS as it is equal to, come to this numerator first term, sin x into d by dx of e power x. What is the value of d by dx of e power x? E power x only. Understood this first term, my children? Right. Minus e power x into d by dx of sin x. What is the value of d by dx of sin x? Right, cos x. So I wrote in the brackets cos x. Understood this second term, my dear children? Whole divided by sin x whole square can be written as sin square x. Understood the denominator part also, my dear children? Right. So I wrote here what are the formulas I wrote used here. I wrote that formulas. D by dx of e power x is equal to e power x, and d by dx of sin x is equal to cos x. I used these two formulas in this step. Okay, my dear children? Right. From these two terms in the numerator, if you observe, e power x is the common factor. So I am taking out the common factor e power x. So e power x into what will you get here? Sin x minus cos x. Understood the numerator part, my dear children? Right. Whole divided by sin square x. This is the value of dy by dx. Understood, my dear children? Right. Previously, I told you there are two methods. Okay, my dear children. So I explained the first method by using the previous knowledge of quotient rule. Now come to the second method. In this method, we use the latest knowledge. What is the latest knowledge? Logarithm properties. In this exercise, we have learnt logarithm properties in the concept. Okay, in the concepts we have learned logarithmic properties. So we use logarithmic properties before differentiating the given function. Understood this part, my dear children? Right. So this method is called logarithmic differentiation. What is this method called? Logarithmic differentiation. Because before differentiating the given function, we are using the logarithmic properties as far as possible. Okay, my dear children? Right. Let y is equal to e power x by sin x. Okay, my dear children? We are considered the given function is y. Now, we are not directly differentiating with respect to x. Observe these steps, my dear children. By taking log, because we are taking logarithm on both sides, not differentiating on both sides directly. First, we are taking the logarithm on both sides. Then we get log y is equal to log of e power x by sin x. Understood this step, my dear children? I have taken log on both sides. Okay, my dear children. This implies log y, we write LHS, is equal to in RHS. If you observe the function, it is in the form of log a by b. What is the logarithm property log a by b? Log a minus log b. So consider, assume this is a and this is b, log of a by b. It is in the form of log of a by b. So we use that formula. So log of a means e power x minus log of b. Log a minus log b. Understood this step, my dear children? Right. I wrote that logarithm property here. See, the log of a by b is equal to log a minus log b. We used this logarithm property. Understood the part, my dear children? Right. This implies log y is equal to, again it is in the form of log a power n. What is the formula logarithm property? What is the logarithm property? Log a power n is equal to n log a. So assume this is a and this is n. So n into means x into log a means log e. Understood this first term, my children? Right. Minus, I am writing the second term as it is. Understood this step, my children? Right. I wrote that logarithm property also here clearly. Log a power n is equal to n into log a. Okay, my children? Right. This implies log y is equal to x into here log e is there. Log e value is 1 because log e here no base is given for the logarithm function. If no base is given, what is considered here? Base e. At the in the concepts we have learned, we have discussed that point. Nothing if base is not given. Throughout this chapter, throughout this exercise, we take natural logarithms. Natural logarithm means base is e. Okay, my dear children. Common logarithm means base 10. Remember these points, my dear children. Here base is not given, so we assume base is e. So log e base e is 1. Understood this first term, my dear children? Right. Is equal to, I am writing the second term as it is. Understood this step, my dear children? Right. This implies log y is equal to x minus log of sin y. Okay, my dear children. By this step, we have used the logarithmic properties at most level. At our level best, we have used the logarithmic properties. After that, we start the differentiation part. Understood this part, my children? Now, differentiating with respect to x. Now, we start the differentiation part from this step. Now, by taking the differentiations, means we are using the differential operator on both sides. What is the differential operator here? D by dx, right? So d by dx of log y is equal to d by dx of x minus log of sin x. Understood this step, my dear children? Right. This implies, if you observe in LHS, d by dx of log y is there. Again, you have to bring back to your mind, bring back your previous knowledge of differentiating the composite function to your mind. Okay, my dear children? So here it is x, but it is in the function y. That function is in the variable y. So composite function differentiation. So assume, consider, imagine that y as x in your mind. That is a composite function differentiation. Chain rule. That is also called chain rule. So we are assuming that this y as x in our mind. So it is in the form of d by dx of log x. What is the formula d by dx of log x? 1 by x. So 1 by, what is assumed as x here? Y. So we write y, 1 by y. Understood this part, my children? Into d by dx of y. Whatever we are assuming in our mind, we have to write that part here. D by dx of y. Understood this part, my children? Right. Is equal to, here two terms are there. X is one term minus log of sin x is the second term. So we can differentiate the terms separately. So d by dx of x minus d by dx of log of sin x. Understood the part in RHS, my dear children? Right. I wrote here the formula also. D by dx of log x is equal to 1 by x. In LHS, we used this differentiation formula. Okay, my dear children? Right. This implies 1 by y into d by dx of y. What is d by dx of y? Dy by dx only. So I wrote here dy by dx. Understood this part in LHS, my dear children? Right. Is equal to, now come to RHS. D by dx of x. What is the value of d by dx of x? 1 minus, again, chain rule. Composite function differentiation or chain rule. Assume sin x in your mind as x. So it is in the form of d by dx of log x. Okay, my dear children, remember this point. Then d by dx of log x, what is the formula? 1 by x. So 1 by x means sin x. We assumed here sin x as x in your mind. So 1 by x means 1 by sin x into d by dx of what is assumed as x in your mind? Sin x. So we take it's a differentiation, sin x. Understood this part, my children? Right. I wrote formulas also here. D by dx of y is equal to dy by dx. D by dx of x is equal to 1 and d by dx of log x is equal to 1 by x. I used these three formulas in this step. Understood, my dear children? Right. This implies 1 by y dy by dx. We wrote LHS part as it is equal to 1 minus 1 by sin x into, what is the formula? D by dx of sin x, direct formula. Differentiations of some standard functions. It is also a standard function, sin x. So d by dx of sin x value is cos x. Understood this part, my dear children? Right. Because d by dx of sin x is equal to cos x. Okay, my dear children? Right. Then this implies 1 by y dy by dx is equal to, I wrote this LHS part as it is equal to, in RHS, 1 minus 1 into cos x. What will you get here? Cos x by sin x. Understood this is second term, my dear children, in RHS? Right. This implies 1 by y dy by dx is equal to, in RHS, I am taking the LCM of the denominators. Then what will you get here? LCM sin x. Then in the numerator, what will you get here? Sin x minus cos x. Understood the numerator part, my dear children? Right. But actually, we have to find dy by dx. Differentiating the given function with respect to x means we have to find dy by dx. But what is there in LHS? 1 by y dy by dx. So here we have to send this 1 by y to RHS. Okay, my children, understood? So this implies dy by dx is equal to, if we are sending 1 by y to RHS, it becomes y by 1. It's a reciprocal. So y into sin x minus cos x by sin x. Understood RHS part, my children? Right. This implies dy by dx is equal to, what is y value? E power x by sin x into sin x minus cos x by sin x. Because y is equal to e power x by sin x. We assumed at the beginning of the question. Okay, my children? Right. This implies dy by dx is equal to, multiply the numerator and denominators. E power x into sin x minus cos x by sin x into sin x. What will you get here? Sin square x. If you observe the answers in the first method and the second method, you get the same answer. Understood the two methods, my dear children? You can follow any method. Which method is easier to you? If you feel first method is easy, you can follow. Or if you feel for second method is easy to you, you can follow. You can write any method. No need to write two methods in the examination. Okay, my dear children? Right.